Good morning. So today we'll be starting about preparation of aromatic amines. So let's see the first preparations, that is reduction of nitro compounds. It gives your primary amine. So when you reduce a nitro compound, you get your corresponding primary amine. So nitrogen amines are normally prepared by reduction of your aromatic nitro compounds. Basically tin, HCl, iron HCl, iron hydrogen, palladium catalyzed hydrogenation reaction, platinum nickel. This can be used for conversion of your nitro to your amino groups. And once you have done with the reaction, you have to treat it with base to remove the hydrochloride salt. So once the reaction is formed, your nitro gets converted to, it will be in hydrochloride form. So it will water soluble. So you have to treat it with your base to neutralize it and get your free aniline. So this is how you convert aromatic amines with the help of aromatic nitro compounds. Okay, so nitrobenzene, when you treat it with your tin HCl or iron HCl or catalytic hydrogenation using palladium carbon, palladium, platinum and nickel, you get your corresponding aniline. So this is the first method of preparation of your aromatic amine. Okay, now let's go for the second. So reduction of nitrile on getting reduced with an help of lithium ion, you get a benzyl. So this is the method for preparation of your benzylamine. So if you want to prepare benzylamine, you take a cyano compound, you treat it with lithium aluminum hydride, and then you treat it with, once the product is formed, treat it with acid to remove the complex. You get your corresponding benzyl amine. So this is a method for preparation of benzyl amine from nitrile cyano compounds. Okay. Next method is Hoffman's degradation of amide. If you might have studied this Hoffman's degradation, where an amide on treatment with sodium hypobromide, that is a mixture of bromine and NaOH, alkaline bromine solution. Okay, so mixture of bromine and NaOH. When you treat it, the amide gets converted into your amine. So this is how you can convert a benzamide into your aniline. This is how you can convert your benzamide into your aniline using Hoffman's degradation reaction. Using Hoffman's degradation, where you convert an amide, that is CONH2, into aniline, benzamide to your aniline by using a base like sodium hydroxide or potassium hydroxide in presence of bromine to give you your aniline. Now let's go for the reactions. So first reaction is formation of your amides. Formation of your amides. So when you treat an acyl chloride with an amine, you get your amides. When you treat an acyl chlorides with an amine, you get your amides. So next is when you treat an amine with an anhydride, acid anhydride, you get your corresponding amides. You get your corresponding amides. So let us say in case of your aniline. So aniline, when it is treated with your acetic anhydride, you get your acid anilide. You get your acid anilide. You get your acid anilide. Similarly, when you treat your aniline with acyl chloride, acetyl chloride, even it undergoes a nucleophilic attack on your carbonyl carbon, there is a loss of chlorine and you get your acid anilide. So this is the way acid anilide is prepared, and this acid anilide is one of the most important intermediate or an compound which is used for preparation of many substituted amines. So this is a method for preparation of many substituted amine. Your bromo, nitroaniline and all can be prepared from acid anilide. So they are ortho, so they are para directing. So you get para substituted products, electrophilic substitution in case of your acid anilide. So this is used for various laboratory preparation of bromone, parabromo aniline and paranitro Such type of compounds can be prepared using your acetanilide, because this acetanilide is weakly activating, and because of the steric hindrance it prevents your ortho attack. So you get major as a para product. So if you want a para substituted product in case of aniline, you convert it into acetanilide and then do the bromination and then hydrolyze the acetanilide to get your aniline. So this is how you prepare a para substituted aromatic substituted aniline. So this is very useful intermediate in your synthetic preparations of compounds. Now next is alkylation of amine. So amine when treated with hydrochloride. Okay, so when amine is treated with hydrochloride acid, it forms quaternary ammonium salt. Okay, when an amine is treated with an hydrochloride acid, it will form an ammonium salt, that is quaternary ammonium salt. So when an amine is treated with an, so the lone pair of electrons in a nitrogen will be involved to form an quaternary ammonium salt. Next reaction is when aromatic primary, see over here, primary aromatic amines form stable diazonium salt. So when you treat it NaNO2 and HCl at 0 degrees Celsius, that is nitrous acid is formed, and that gives your Benzenediazonium salt. So look carefully of this reaction. So when primary amines are treated with NaNO2, sodium nitrite, along with HCl at 0 degrees Celsius, the temperature is very important. When it is treated with NaNO2 and HCl at 0 degrees Celsius, you get a Benzenediazonium salt. Okay. Now so let's see the next reaction. Same nitrous acid, when you treat it with secondary aromatic or aliphatic amine, you get a nitrosoamine. You get a nitrosoamine. Very important reactions to be remembered, how to differentiate it between the two primary and secondary amines. So when you treat it with nitrosoamine, sodium nitrite, you get an nitrosomethyl aniline. So if it is a secondary amine, it is treated with NaNO2, you get a nitrosomethyl alanine. This is how you can differentiate between your primary and secondary amine. Now what happens? Okay, isocyanide formation, nitrile formation. Okay, so when the amines are heated with chloroform and alcoholic KH, they produce a foul odor of isocyanide, RNC. See, cyanide is CN, isocyanide is NC. You form an, see the R dash and positive charge on the nitrogen and the negative charge on the carbon. So you get an isocyanide. So when you treat your amine with chloroform and KOH, you get a zwitterion. Okay, that is both the charge, positive and negative charge will. That's why they are called zwitterion, because the nitrogen has positive charge and your carbon has a negative charge. So you get both the charge on the compound. So they are called as zwitterion. So this amine, when you treat it with an chloroform and alcoholic KH, you get your corresponding isocyanide. So when aniline is treated with this, you get isocyanide of your aniline, benzene isocyanide. So this is your reactions of your aniline. Now benzene, how diazonium salts are formed. So when aniline is treated with nitrous acid in presence of HCl, you get your diazonium salt, C6H5N2 plus Cl minus. So this takes place only at low temperature, below 10 degree Celsius. So reactions, see these diazonium salts which are formed, they are intermediate for many of the reactions. Okay, very useful intermediate in preparation of many compounds, and this should not be kept at a high temperature because it decomposes, liberates nitrogen, and it is a highly explosive reaction. Okay, this reads and forms an highly reactive cation, that is an electrophile. and the cation reacts with any anion present in the solution to form the corresponding compounds. So this is what. So these are some of the reactions. So that's the reason why the benzenediazonium salts, benzenediazonium salt which are formed, they should be preserved at the low temperature, otherwise it decomposes. You don't get a coupling product. So these are some of the reaction which is observed in case of diazonium salt. So when a benzene diazonium chloride which is formed in the previous, when you warm at room temperature and you treat it with water and cuprous oxide, you get your phenol. When you treat it with your cuprous chloride, you get your chloro derivative. Cuprous bromide, you get your bromobenzene. When you say cuprous chloride, cuprous cyanide, you get a cyanide. Then if you're Ki, you get your, if you treat with fluoroboric acid, heat it with fluoroboric acid, you get your fluorine. And if you treat with orthophosphoric acid, you get your benzene. So these are the various uses of diazonium salts. So what happens when you heat benzene diazonium salt, you get and treat it with other reagents. Like if you treat it with water, you get your phenol. If you treat it with cuprous chloride, you get your chlorine derivative, that is chlorobenzene, bromobenzene, cyanobenzene, okay, iodobenzene and all. So this is how you can prepare various intermediates which is required in your synthetic application. So this particular benzene diazonium salt is very important intermediate. You can prepare n number of compounds using benzene diazonium salt, that is chloride. Okay, so this is the important, and these are some of the reactions that diazonium salts undergo. So they can undergo coupling reaction. We get a diazo compound. The various number of various dyes are prepared using your arrived diazonium salts. I'll be explaining it in detail later on also, but these are some of the reactions. You can see lot of dyes and all can be prepared. If you reduce it, you get an hydrazine. If you couple it with an phenol, you get an diazocoupled product, that azo product, which is used as an indicator for detection of your phenol. And with aniline and all, various dyes can be prepared. So various coupling reactions can occur with the benzene diazonium salt depending upon the temperature. At low temperature it will give azocoupled product, at high temperature it undergoes displacement reaction to give you a substituted products: fluoro, iodo, cyano, bromo, chloro, benzene and phenol. And others at lower temperature it will undergo to give you an azo product. Okay, the next reaction is when the amines are oxidized with potassium dichromate or KMnO4, you get an dianone, okay, cyclohexa 3,5-diene or quinone, okay. So this is your product. So this is similar to that of your phenol. So aniline, when treated with potassium dichromate, you get cyclohexa 3,5-diene 1,4-dione. So this is the oxidation product of your amine. So it undergoes one more reaction, that is Hofmann-Martius rearrangement. So when your dimethyl aniline is treated with your hydrochloride is treated with your heated at high temperature, it undergoes displacement reaction. It undergoes displacement reaction and you get an ortho-para substituted methyl. You get an ortho-para substituted methyl. The methyl from your nitrogen gets shifted to that of your ortho and para position, similar to that of your Friese rearrangement. Okay, that is in case of phenol. So what happens when an N-dimethyl aniline hydrochloride is heated at high temperature? You get your corresponding para and ortho-para substituted methyl group. Your alkylation takes place at your ortho and para position. And when you treat it with your NaOH, you get your free base. So this is nothing but your Hofmann-Martius rearrangement, where the N-dimethyl aniline, when heated at hydrochloride, when it is heated at 300 degrees Celsius, it undergoes rearrangement. You get an orthopara substituted alkyl group or a methyl group. Okay, this on treatment with base, you get a free base of 2,4-dimethyl aniline. This is how 2,4-dimethyl aniline can be prepared with from NN-dimethyl aniline. Okay, this is the method for preparation of 2,4-dimethyl aniline from NN-dimethyl aniline. So this is known as Hofmann-Martius rearrangement reaction. It is an thermal reaction which takes place at high temperature. Moreover, aniline is an electron donating group, so it undergoes electrophilic substitution reaction at orthopara position. So you can just replace your carboxylic, no need of writing carboxylic, just treat aniline with bromine, you get a tribromo aniline, you get a tribro. You treat aniline with nitrogen, it on a trinitro aniline. So this is how your various because it is an highly activating group. It is an highly active because it has got a lone pair of electrons, so they will act as an orthopara director. So electrophilic substitution will take place at ortho and para position. That's why you get 2,4,6 tribromo aniline. The formation of salts, as I said earlier, also when you treat it with HCl, you get its corresponding quaternary salt, that is hydrochloride salt. Benzenediazonium, you get your corresponding benzenium chloride. Okay. So these are some of the reactions of your aniline. Now let's go for the qualitative test. How do you determine aniline? Okay, if you are given a sample, how do you determine aniline? It's aniline or not. So what do you take? So first step is azodye test. So first thing is azodye. You take 1 drop of aniline, you add dilute HCl until it dissolves. So you have to make a clear solution. Then add NaNO2 solution until pale yellow color is formed. So this represents the formation of, and the reaction should be at 0 degree using ice. The mixture has to be cooled using ice. Then add few drops of, make a preparation of phenol in 10% NaOH and cool it. Then add this azodye to the phenol solution gradually, slowly you have to add. So as you add with temperature maintaining at 0 degrees. So as you gradually add it, you get a orange red PPT or color. That means this dye has been formed. Azodye has been formed. The double bond acid will be formed. So this thing is your azodye. As you can see down. So aniline when treated with form benzenediazonium chloride. This benzenediazonium chloride will react with beta-naphthol. Okay, in case beta-naphthol is always mostly used at 0 degrees, you get an azodye, that is orange red colored dye. This is a test for determination of your aniline. Next is acetylation test. You take 5 ml of aniline, you add acetic anhydride, reflux it for 20 minutes. This is, so once you know that this is an aniline, so to derivatize this, you do acetylation. This is an derivatization of acid aniline. So you take aniline, you add 20 ml of acid, reflux it, pour into air, you get a white PPT of anilide. You get a white PPT of anilide, acetanilide. So this thing is your confirmatory test. That means once the aniline is confirmed, when you do, and if you get this derivative, then means it is 100% sure that your compound is aniline. This is a confirmatory test for aniline. So now let us see some of the analytical things. How do you infer that it is aniline using analytical tools? So let us go for IR. So IR shows NH stretching for functional group at 3500 to 3000, around in between 3500 to 3100. It will show an NH stretching. You can see in the diagram it is so. So you can see the various NH primary stretching and your shoulder bands in IR spectrum. Moreover, you can see aromatic CH group stretching at around, if you can see it over, if you see this thing, what is shown over here, this is nothing but your CH aromatic stretching. And there is NH bending at around 6100 1619 and CN stretching at 1280. This if this and NH wagging at 764. If these things are there in your NMR spectra, then you can say that this compound contains an aniline type of linkage. Okay, the functional group present is aniline. So from this all things, CN stretching, NH bending of primary and NH stretching of primary and your CH stretchings of your aromatic compounds, you can analyze that this particular compound is your aniline. Okay. Next thing is uses of aniline. Aniline is used in variety of such as polyurethane foams, agriculture chemicals, synthetic dyes, antioxidants, stabilizers for rubber industries, herbicides, varnishes, and explosives, and it is also used in pharmaceutical industry. Now let us see some of the compounds where aniline has a major role to play. First is your paracetamol. It is para-hydroxyacetanilide. Okay, this is one of the most common drug which is used by you. So it is an anilide which contains an hydroxyl group at a para position. Next examples are your sulfonamides, which are antimicrobial in nature. Wide variety, it can be used for topical application, sulfadiazine, any sulfonamide. They contain a basic aniline ring which is connected to an sulfonamide, and this aniline NH2 is very important for the activity. Some of the examples of sulfonamides, like if the R is replaced by your 1, 2, 3, 4, that is 3,5-dimethyl pyrimidine, then you get your sulfamethoxine. If it contains pyrimidine moiety attached to your sulfonamide, it is known as sulfadiazine. And if it contains an methyl substituted isoxazole, then it is known as sulfamethoxazole. And these are all having antimicrobial property. These are all having antimicrobial properties. Some of the examples, see this crystal dye, violet dye, they are used as a dye as well as they are used as for their antimicrobial properties. So if you can see, it is a fused 3-N-dimethyl aniline which is fused to another 3-N-dimethylamine. So these are used in dye as a dye as well as an antimicrobial agent in various preparations. Other examples as an indicator, methyl orange, you might have used it in your titration. So methyl orange is also an example of an N-diazo compound which is formed by treatment of N-dimethyl aniline with your benzene sulfonic acid. You get a diazonium salt, and this thing can be used for the detection of your acidic to basic titration. So in case of acidic medium, okay, when it is in acidic medium, it will be red in color, and if when it is in basic medium, it will be in yellow color. So depending upon the condition, so if it is in acidic condition, it gives red color, and if it is in basic condition, it will be yellow in color. So this compound can be used as an indicator in your titration. Okay, so they can act as an indicator. They have an antipyrite. They are used in various agriculture products, as in rubber industry, in for preparation of various dyes, for in the dyeing industry, all these things, as well as sulfonamides, and there are various sulfonyl ureas. They all contain aniline moiety, okay, which are used in diabetics. So examples are many. So this aniline is a basic commodity in most of your compounds. Now let's go for diazonium salts. Let's go for diazonium salt formation. This comes for your 5 marks. Separately comes for 5 marks. Write a note on diazotization. Write a note on diazotization. So what it is? The nitroso of your primary aromatic amine with nitric acid, so nitrous acid. So when it is generated by treating sodium nitrite with a strong acid such as hydrochloric acid, sulfuric or fluoroboric, leads to diazonium salt, which is isolated if the counterion is non-nucleophilic. So this can be isolated if there is no other counterion. So it forms a diazonium salt which can be isolated. at 0 degrees only, 0 to 5. It is only stable at 0 to 5 degrees Celsius. If it further gets heated, it gets decomposed. Diazonium salts are important intermediate for preparation of halides using Sandmeyer's reaction and Schemann's reaction. Sandmeyer's reaction, you can prepare your cyano, chloro and bromo, and wherein Schemann's reaction, you can prepare your fluoro compound. It is also used as an intermediate for preparation of various iso compounds, that is dyes. The very important thing is the temperature above 5 degrees. The diazonium in aqueous solution are known to decompose and explosive in nature. That's why your diazotization should be done at 0 degrees, or else it decomposes into with the release of nitrogen, it forms a very reactive electrophile which can react with anything, highly reactive species. Okay, so that's why the temperature should be maintained at 0 degrees of the diazonium salt. Temperature too low, however, causes crystallization. So the temperature should be between 0 to 2. And if you try to dry it, it will explode. If you try to dry it and isolate, it is an highly explosive compound. So you should be very careful when you are handling diazotization reaction. Either you have to dry it fully, it should be in the solution phase, as well as it should be at the temperature should be around 0 to 5. If it is below 2 cold, then also it is a problem. It will crystallize out and it will not react. And if it is if the temperature is too high also, it will decompose into nitrogen and it becomes a very highly reactive electrophile. Okay, so the temperature plays a very important role in diazotization. Will plays a very important role in diazotization. Now let us see what happens in the diazotization. First is your NaNO2, sodium nitrite, reacts with HCl to form HNO2, that is HONO, that is nitrous acid. Okay, and this nitrous acid will then reacts with your aniline to form your diazonium salt, or they only react with your primary amine to form a diazonium salt, whereas secondary amines do not give you a diazonium salt. It forms a nitroso derivative. So this is only used in case of primary amine. Very important thing to be remembered. Now let's go for the steps involved in diazotization. Let's go for the steps involved in diazotization. So diazotization mechanism. So this is very important to be known. So diazotization reaction begins with the reaction of nitrous acid with another acid. So you got HNO2 and HCl inside in your reaction vessel. So what does this another acid do? It will protonate your nitrous acid. There is a loss of water to form nitrosonium ion, that is NO ion. Okay, first step is protonation of your nitrous acid by another corresponding acid which is present in the reaction. To protonate the nitrous oxide, there is a loss of water and nitrosonium ion is formed. That is the first and foremost step in your diazotization. This thing is, what is the next thing? This nitrogen ion reacts with aromatic ring to which NH2 is attached. So this is an electrophile. So an amine has an aniline or any aromatic amine, aniline, that is aniline has an lone pair of electrons. This lone pair of electrons will donate an electron to the nitrosonium ion. Okay, there is a donation of electron from your aniline to your nitroso group and nitrosonium ion. Okay, there is an donation of lone pair of electron from your aniline nitrogen to the nitrogen of your nitrosonium group. So in doing so, the amine in your aromatic aniline gets protonated, gets positive charge. The positive charge of the is now shifted to the nitrogen in which directly attached to the aromatic ring. So does the charge from your nitrosonium ion get shifted to the nitrogen in your amine group which is attached to your aromatic ring, and a new nitrogen-nitrogen bond is formed. You can see a diazonium NN bond which is formed, and the subsequent deprotonation gives nitro. So there is so once this nitrosonium ion is formed, it undergoes deprotonation. There is a loss of proton. Okay, there is a loss of proton uh, to get your nitrous and nitrosoamine. So this is the first step. You get an nitrosoamine. You get an nitrosoamine. So your nitrosoamine is formed. So what is the next step? Once that n-nitrosoamine, now in presence of this reaction takes place in excess in acidic medium. So in next, what happens in excess of acid, the n-nitrosoamine which is formed gets converted into diazohydroxide by protonation and subsequent deprotonation. The n-nitrosamine gets protonated. The oxygen of your nitrosamine gets protonated. So in doing so, then there is a rearrangement. Okay, it gives you rearrangement, and further again they will lose a proton. So they will undergo rearrangement to give you a diazohydroxide intermediate. It will give you a diazo. Why it is called diazo? There are two nitrogen and an hydroxide group attached to it. It gives you a diazohydroxide intermediate. And this further, this diazohydroxide which is formed in the previous step gets protonated again. The OH gets protonated again in the acidic medium. There is a loss of water, and this loss of water leads to your formation of your diazonium salt, which gets resonance stabilized. So this is the mechanism of action of your diazotization. First step is nitrosonium ion formation. And then next is attack of your lone pair of electrons from your aniline to the nitrosonium ion. This leads to your formation, and with the loss of proton, which leads to formation of nitrosoamine. This nitrosoamine, since it is in acidic medium, gets protonated. There is a protonation and deprotonation process occurring. This and rearrangement occurs due to this, and you get a diazohydroxide derivative. This diazohydroxide derivative gets protonated, and there is a loss of water to give you a diazonium ion. To give your diazonium ion. So this is a mechanism of action how the diazotization takes place. This is the mechanism of action how diazotization takes place. So that was the mechanism. Now let's go for the coupling reaction. What happens? Now this diazonium salt is formed. So the compounds such as aniline phenols, which contain strong electron donating groups, that OH and N, that activate the ortho and para position on the benzene because they are ortho, can undergo coupling reaction with their diazonium. So what does this do? These diazonium salts are positive charge, and this phenol and anilines, they have got ortho para director. So they will try to increase the electron density in your ortho and para position. Though this will promote the diazo coupling. So the azo compound which is positively charged will react with your diazo, with your phenols and anilines to give your azo compounds. They will couple together. These two rings will couple together and you get a azo group. And the coupling occurs at para, ortho or para position because they are ortho para. Mostly it occurs at the para position because they are ortho para directed. Aniline may serve as a substrate for the formation of diazonium salt, and it may serve as a substrate for your coupling reaction with diazonium. So if you use excess of aniline, they can undergo self-condensation, self-coupling reaction to give a azo-coupled product. The reaction is an electrophilic aromatic substitution reaction, as I mentioned, because your diazonium salt will act as an electrophile, and this mechanism similar to that of your nitration of your benzene. It's a two-step reaction. First is attack, stabilization, and loss of your proton to get your azo coupled reaction. So these are the reactions. So what happens? Attack on the diazonium salt, then there is a loss of proton to get back your aromaticity and you get your diazo product. Aniline and phenols can react to give your diazo products. Okay, this is the reactions, and this is the applications of diazonium salt. So they can Sandmeier's reaction is nothing but when you treat your diazonium salt with cuprous chloride, you get your aryl chloride, that is benzene, chlorobenzene. Yeah, no, with cuprous bromide, you get your bromobenzene. When you treat it with cuprous cyanide, you get your cyanobenzene. When you treat it with potassium iodide, you get an iodobenzene. This is one of the preparation that we will be doing in practicals. And when you treat it with H2SO4, when you heat it with H2SO4 and water, you get your phenol. When you treat it with fluorobaric acid, that is your Schemann's reaction, you get your fluorosubstituted benzene. And when you treat with orthophosphoric acid, you can convert a diazonium salt into your benzene. So it is an example of reduction. So these are the applications. So all these intermediates plays a very important role in synthesis of various compounds. Your diazonium salt also, as I said, it is used in coupling reactions, which are used in preparation of various dyes, So uses of azo compounds, they are used in dye industries. The NN dye, the color results from joining of the two delocalized electrons via NN bond, and the color can be altered by changing the number of functional groups attached. By changing the functional groups, we can get different color type, and the color changes depending upon the acidic medium. On the acidic medium. Okay, depending upon the acidic medium or the basic medium, the color changes. So some of the uses of diazonium compounds are listed below. Like they are used in pigment dye industries. They are used in the synthesis of various hydrazines, derivatives with the help of stannous chloride, and they are used as the standard reagents for various synthetic organic compounds. So these are the applications of diazonium compounds. Very important intermediate in your synthetic chemistry. Very important intermediate in your synthetic. It is used in Fischer-Indol synthesis, where hydrogen gets reduced to your with the help of stannous chloride. Okay, so these are some of the various important compounds that are synthesized. Okay, using